Okay, so now let's move on to some factoring problems. Let's start with this problem. This is a polynomial in M. The goal is to factor this completely. Well, actually, this is not too different from the last problem we worked on in one respect, which is that if we're looking at m to the fourth minus 49, we can rewrite this. Okay, we can rewrite this because m to the fourth is the same thing as m squared squared. Okay, and 49 is the same thing as 7 squared. Okay, so if you look at m squared as a term onto itself, and 7 here, if we let a equals m squared, and we let b equal 7, we can say that m squared squared minus 7 squared is equal to a squared minus b squared, which is the same thing as a plus b times a minus b. And then we can substitute back in for a and b in this expression. Let's do that. So we've got m squared squared minus 7 squared is equal to m squared plus 7 times m squared minus 7. And that is the answer. That is about as far as you can go in factoring this expression. We also have to remember how to factor quadratic equations. And here we've got a quadratic equation. Okay, so it may not immediately look exactly like a quadratic equation, and that's because it's not in standard form. We've got to get the zero we've got to get a 0 to the right of the equal sign. So let's take n squared plus 30 equals negative 11n, and let's convert that to standard form. We've got to get this into standard form, which means we're going to have to add 11n to both sides. That gives us a 0 on the right side, and it gives us n squared plus 11n plus 30 on the left side. In order to solve this equation, it says solve by factor. We've got to factor the left side. We know it's going to look something like this. It's going to be n and n, two factors, each of which have n. But what are the remaining terms? Remember the magic X method? This is a method I've used a lot in my Algebra 2 classes. And to use the magic X method with a quadratic equation, you've got to take the constant term, put it on top. We put 30 on top. And then you've got to take the coefficient of the variable to the first power, which is 11 here, and put that on the bottom. Got to remember also the top is the product, and the bottom is the sum. And the goal is to find two numbers that, when multiplied together, give you a product of 30, but when added together, give you a sum of 11. A little bit of thought will help you to come up with 5 and 6. Okay, you can simply just try all the perfect factors of all the whole number factors of 30. 10 and 3, for example, would not work. If this was 10 and 3, they would multiply to 30, but they would add up to 13. Okay, but in this case, 5 and 6, they multiply to give you 30, and they add together to give you 11. 5 and 6 means that the two factors are n plus 5 and n plus 6. Okay, so you simply take these numbers and you just plug them in those spaces that we had. So we've got the equation n plus 5 times n plus 6 is equal to 0. Anytime two numbers are multiplied by each other and give you 0, it means either one of the numbers is 0 or another one of the numbers is 0. There's no other way. If neither of these were 0, you could not get a 0. So that means that either n plus 5 equals 0 or n plus 6 equals 0? Well, the solution to the first equation is n equals negative 5. The solution to the second equation is n equals negative 6. So our overall solution to this problem is the solution set negative 5 and negative 6. Okay, so that is the answer to this. Let's move on to another kind of problem, simplifying some radicals. Okay, and these are mixed radicals. If you take a look at this one, this first one's a little hard. It's a cube root, so we're starting with a sort of a harder problem here, cube root. And not only is it hard because it's a cube root, but it also has a number multiplied by a variable. You've got 625 times r to the 4th. So we've got a lot of things going on here. We've got to remember how we're going to simplify this. Well, we sort of do it by dividing and conquering. Okay, divide and conquer. Let's take one thing at a time. Let's talk about the number first. Because remember, we can break this cube root of 625 times r to the 4th up into the cube root of 625 by itself, okay, times the cube root of r to the 4th by itself. You can multiply under the radical signs if the radicals are similar. In this case, they're both cube roots. So this allows us to divide and conquer and to be able to look at each of these two as separate problems and then combine the answer later on. So how do we do the cube root of 625? Well, we have to kind of remember what our perfect cubes are. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed, let's keep on going here, 5 cubed is 125, 6 cubed equals, well, I got to figure that one out. That's sort of where I run out. 36 times 6, 6, 12, 18, 19, 20, that's 216. Okay, 7 cubed, 49 times 7, 63. That'd be, I think, 343. Let me check that again. 63, 7 times 4 is 28. 343. Well, obviously, these are too big. We've got to find the perfect cube that divides evenly into 625. And the answer happens to be 5 cubed or 125. So 125 is the largest perfect cube that divides evenly into 125. Into 625. So we can remove that perfect cube from underneath the radical sign. So let's go down here. We have the cube root of 625. 625 is 5 times 125. So we have the cube root of 5 times 125, which is the same thing as the cube root of 5 times the cube root of 125. Well, the cube root of 5 we cannot do anything with. There's no way to simplify it further, but we did say that 125 is a perfect cube. It's 5 cubed, so we could replace this by 5. So this gives us 5 times the cube root of 5. So this is our numerical part of our answer. 5 times the cube root of 5 is our numerical piece. We're halfway there. Let's go back up here to the cube root of r to the 4th. Well, what is the largest perfect cube that's in r to the 4th? And I think it doesn't take long to realize that that's got to be r to the 3rd, because the cube root of r to the 3rd is equal to r. Remember, a cube root and a cube cancel each other out. Okay, so if we're starting with the cube root of r to the 4th, we then know r cubed is the largest perfect cube. We can say that's equal to the cube root of r cubed times r. So we're going to factor out the perfect cube, which is the same thing as r times the cube root of r. Okay, we simply, I'll show you an intermediate step here. This is the cube root of r cubed times the cube root of r, and the cube root of r cubed is just r. Okay, so we've got our answer, which is 5 times the cube root of 5 times r times the cube root of r. But normally what we do is we kind of keep like terms together. I mean, this is a correct answer, but it's a little bit nicer to say it in a way where we're multiplying the two numbers which share the same radical, and then we're going to multiply the numbers that don't have a radical together, so we're going to change the order of this. And this is the same thing as 5 times r times the cube root of 5r. Okay, so that is the final answer. We're going to continue to look at other types of problems, including exponent problems and trigonometry problems, in the next video.